On May 26, 1991, a Boeing 767 flying over the jungles of Thailand literally tore itself apart in midair. Both wings ripped clean off. The tail section separated, and 223 people fell 17,000 feet into the darkness below. There were no survivors. No mayday call. No warning. Just a perfectly functioning airliner that suddenly became a death sentence for everyone on board. The pilots fought for control. They followed their training. They did everything right. And it didn't matter, because the plane was fighting them. Something on that aircraft had a mind of its own, and it was trying to kill them all. What caused this nightmare? Just one. A mechanical component smaller than your fist that wasn't supposed to move during flight. But it did. And when it did, it activated a system that turned one of aviation's greatest safety features into a weapon. This is the story of Lauda Air Flight 004. Every single wide-body jet in the world had to be grounded and fixed, because if it could happen to a brand new Boeing 767, it could happen to any of them. Let's rewind to the night of May 26, 1991, and figure out how something so small created one of aviation's most horrifying disasters. Lauda Air was at the time basically aviation royalty. Yeah, that Niki Lauda, the Formula One legend who survived being burned alive in a racing crash and came back to win 2 more championships. The guy knew a thing or two about defying death. He also knew quality. Lauda Air had one of the youngest, most modern fleets in the sky. Their 767s were practically fresh off the assembly line. Flight 004 was scheduled to fly from Bangkok to Vienna, with a quick tech stop in Hong Kong to refuel. Nothing unusual about that. The Boeing 767 was a workhorse. Reliable, efficient, loved by pilots and airlines alike. It had only been in service for about a decade, and Boeing was pumping them out like hotcakes. This particular aircraft, registration Oscar Hotel Lima Alpha Whiskey, had logged barely 1,000 flight hours. In aircraft years, that's basically a newborn. The flight crew was top tier. Captain Thomas Welch, 51 years old, American, with over 15,000 flight hours. His first officer, Josef Thurner, 58, Austrian, even more experienced with 16,000 hours in the air. These weren't rookies. These were seasoned professionals who'd seen everything. Or so they thought. 213 passengers boarded that night. Business travelers, families, all expecting a routine red-eye flight. Among them were 38 people from Hong Kong heading to a travel fair in Vienna. There were honeymooners. There were kids. Just regular people looking forward to landing safely halfway around the world. The plane pushed back from the gate at 11:02 p.m. local time. Right on schedule. Everything was nominal. That's pilot speak for boring, which in aviation is exactly what you want. The 767 taxied to the runway. The engines spooled up, and at 11:18 p.m., Flight 004 lifted off into the humid Thai night. Climb out was smooth. Air traffic control handed them off as they ascended through the darkness. The pilots were relaxed. The flight attendants began preparing the cabin service. Passengers were settling in, pulling out books, adjusting their seats, maybe ordering a drink. Just another night above Southeast Asia. By 11:31 p.m., just 13 minutes after takeoff, Flight 004 had reached 17,000 feet and was still climbing toward its cruising altitude of 37,000 feet. They were about 100 miles northwest of Bangkok, flying over dense jungle and mountains. Below them, nothing but darkness. The nearest town was miles away. If something went wrong out here, help wasn't exactly around the corner. And that's when everything went to hell. Without warning, without any indication from the cockpit instruments, the left engine's thrust reverser deployed. Now let me explain what that means, because it's important. A thrust reverser is basically a system that redirects engine thrust forward instead of backward. You use it when landing. It helps slow the plane down on the runway. It's a safety feature, a good thing. Except when you're at 17,000 feet, climbing at 300 miles per hour, and one of them activates on its own. Imagine driving down the highway at full speed and suddenly your left tire decides to slam on its brakes while the right one keeps accelerating. That's essentially what happened to Flight 004. The left engine was now pushing the aircraft backward and sideways, while the right engine continued shoving it forward. The 767 immediately began yawing, rolling, and pitching in ways no aircraft is designed to handle. Captain Welch and First Officer Thurner had maybe 2 seconds to process what was happening before physics took over. The flight data recorder, that black box everyone talks about, captured everything. And what it captured was pure chaos. Hard. The pilots fought it. They pushed the yoke right. They adjusted the rudder. They reduced power on the right engine, trying to balance things out. Standard procedure. Textbook stuff. But the thrust reverser was overpowering them. It was like trying to steer a car with one wheel locked up at highway speed. You can turn the steering wheel all you want. The car's going where physics says it's going. Within seconds, the 767 entered an uncontrolled roll, then dipped more. The aircraft was basically doing a barrel roll that it had no business attempting. The stress on the airframe was immense. We're talking about forces that metal and rivets and composite materials just weren't designed to endure. At 17,000 feet, the 767 rolled past 90 degrees. The passengers were now upside down or close to it. Bags, food, drinks, people who weren't buckled in, everything became projectiles. The cabin was screaming. Not just people. The aircraft itself was screaming. Metal was bending. Rivets were popping. The wings were flexing beyond their limits. And then the wings did what overstressed wings do. First, the left wing separated. Just ripped clean off the fuselage. 180 feet of aluminum, fuel tanks, engines gone. When one wing goes, the asymmetric forces tear the other one off like pulling wings off a fly. The tail section separated next. The fuselage, now just a hollow tube with no lifting surfaces, began its terminal descent into the jungle below. 223 people fell through the night sky. Some were still strapped to their seats. Others were ejected during the breakup. The wreckage spread over an area almost 2 miles wide. The main fuselage hit the ground at over 500 miles per hour and disintegrated on impact. There was no miracle survival story here, no last-minute save. Just instant, total destruction. The last thing the cockpit voice recorder captured was the pilots fighting. Not with each other, with the aircraft. You can hear the strain in their voices, the grunts of physical effort. They're pulling on the controls with everything they have. And then nothing. The recorder stops, because the aircraft doesn't exist anymore. When dawn broke over the jungle, rescue teams started arriving. What they found defied comprehension.
Wreckage was everywhere.
Body parts were scattered across treetops. The main debris field was a crater. Investigators would later say it looked like a bomb had gone off, which in a sense, it had. The kinetic energy of a 150-ton aircraft hitting the ground at terminal velocity is roughly equivalent to a large explosive device. But here's where it gets interesting. This wasn't a bomb. This wasn't pilot error. This wasn't a maintenance issue. This was a design flaw that Boeing, the FAA, and every airline in the world somehow missed. Investigators from Thailand, Austria, and the United States descended on the crash site. They had to. This was a brand new aircraft from a reputable airline, flown by experienced pilots in perfect weather. Something was very, very wrong. And if it could happen to Flight 004, it could happen again. They recovered the flight data recorder and the cockpit voice recorder. Both were damaged but readable, and what they showed was impossible. The thrust reverser on the left engine had deployed during flight. Thrust reversers don't do that. They're mechanically locked during flight. Multiple systems are in place to prevent exactly this scenario. It would be like your car's airbag randomly deploying while driving. It's not supposed to be possible. Boeing was confident. They insisted it couldn't happen. Their engineers swore up and down that the design made uncommanded deployment impossible. The FAA backed them up. Airlines kept flying their 767s. And Niki Lauda, who'd already lost 1 aircraft and 223 souls, was absolutely furious. Lauda didn't just own the airline. He was a pilot himself. He knew aircraft. And he knew Boeing was wrong. So he did something almost unheard of. He got personally involved in the investigation. He flew to Seattle. He confronted Boeing executives. He demanded answers. He demanded tests. Boeing, under pressure from Lauda and international investigators, finally agreed to run a simulation. They'd take a 767, fly it to altitude, and manually deploy the thrust reverser to see what would happen. Could the pilots recover? Was it survivable? Boeing's engineers were sure the pilots would regain control. The 767 was a tough aircraft. Surely it could handle it. They were wrong. On October 2, 1991, 5 months after Flight 004, a test 767 took off with a skeleton crew. Just pilots, engineers, and enough instrumentation to measure every possible data point. At a safe altitude over empty ocean, they manually activated the thrust reverser on one engine. The aircraft immediately became uncontrollable. Who were prepared, who had their hands on the controls, couldn't save it. The 767 entered the exact same death spiral as Flight 004. They barely managed to shut the system down and recover before it was too late. And even then, the aircraft was seconds from structural failure. Boom's engineers went white. The FAA went into emergency mode. And every single Boeing 767 in the world was grounded within 24 hours. Not just the 767 actually. The 747, the 777, every wide body with thrust reversers got a hard look. Airlines were ordered to inspect and modify the systems immediately. But what exactly went wrong? How did a system with multiple safeguards fail so catastrophically? The answer was both simple and infuriating. A single valve inside the thrust reverser system could, under extremely rare circumstances, move slightly out of position during flight. It wasn't supposed to. The odds were astronomical. But it could. It could allow hydraulic pressure to leak into the deployment system. Not enough to fully deploy the reverser immediately, but enough to start the process. And once it started, there was no stopping it. The valve was supposed to be held in place by pressure differentials and mechanical locks. But at certain altitudes, certain speeds, certain hydraulic pressures, those locks could momentarily release. We're talking about a window of failure, maybe a few seconds wide. But that was enough. Once the valve moved even slightly, hydraulic fluid began flowing where it shouldn't. And in the Boeing 767's thrust reverser design, there was no backup system to stop it. No warning light. No alarm. Nothing. The pilots of Flight 004 had no idea what was happening until the reverser was already deploying. By the time they realized physics had already won, the aerodynamic forces were too much. No amount of training or skill could save them. Boeing implemented fixes. They added redundant locking mechanisms. They modified the hydraulic systems. They installed warning systems that would alert pilots if a reverser even thought about moving during flight. And they issued a directive that, if a thrust reverser ever deployed in flight, pilots were to immediately reduce power on that engine to idle, not try to compensate with the other engine. Fighting it only made things worse. The families of the 223 victims sued Boeing, but they won. Boeing settled for undisclosed amounts, but reports suggest it was one of the largest aviation settlements in history at that time. The company never admitted fault publicly, but the fix they implemented told the whole story. You don't ground every aircraft worldwide and redesign a major system because everything was working fine. Niki Lauda never flew a 767 again. But the crash haunted the airline. It haunted Lauda personally. He'd built a company on safety and reliability. And despite doing everything right, 223 people died on his aircraft. That's a weight that doesn't lift. The crash of Flight 004 changed aviation in ways most passengers never knew about. Every thrust reverser system on every commercial jet was reevaluated. New regulations were written. Testing procedures were updated. The idea that a single component failure could destroy an aircraft was no longer acceptable. Redundancy became mandatory. Warning systems became standard. Today, if you're flying on a commercial jet, your thrust reversers have multiple backup systems. They have sensors that constantly monitor their position. If one even twitches during flight, alarms go off in the cockpit, and the system automatically locks. What happened to Flight 004 can't happen anymore. Not because it was unlikely, but because it's been made impossible. But here's the thing that keeps aviation experts up at night. For almost a decade, hundreds of 767s flew millions of passengers with this flaw. Most of those flights were perfectly fine. The odds of the valve moving at exactly the wrong moment were tiny, but they weren't zero. And on May 26, 1991, those odds came up. 223 people paid the price for a design flaw that should have been caught before the first 767 ever carried a passenger. The wreckage of Flight 004 was eventually cleared from the jungle. A memorial was built near the crash site. Families visit when they can, though it's not easy to reach. The Thai government maintains the site, and locals still remember the night the sky rained metal and fire. Captain Welch and First Officer Thurner were exonerated completely. The investigation found they did everything possible. They followed procedures. They fought the aircraft until the moment of impact. They were good pilots caught in an impossible situation. Because they were victims too, Boeing never publicly apologized. That's not how corporations work. But they did pay. And they did fix the problem. And to their credit, they cooperated fully with the investigation once the evidence became undeniable. Could they have acted faster? Absolutely. Should they have tested for this scenario before putting the 767 into service? Without question. But they didn't, and 223 people died because of it. The crash of Lauda Air Flight 004 is a reminder that flying is only as safe as our ability to imagine worst-case scenarios and design around them. Engineers can't predict everything, but they have to try, because when they miss something, when they say that's impossible, instead of let's make sure it's impossible, people die. Next time you're on a plane and you hear those thrust reversers roar to life after landing, slowing you down on the runway, remember Flight 004. Remember that system used to have a flaw. A tiny, almost impossible flaw, but it was real. And now it's not. That's how aviation safety works. Written in blood, fixed in metal, and hopefully never repeated.